Okay, our final section for Chapter 11 is all about aromatic compounds. Notice with the aromatic compounds we have the single and double bonds. That's characteristic of it. They call it aromatic compounds because when they realized that there was a lot of aromas involved in something, a lot of times they had this compound involved. This is called a benzene ring. It has 6 carbons and a hydrogen bonded to each of them. And they alternate in double single bonds. There's a double bond here and a single bond here. If you compare the left and the right molecules, on the left hand side, the double bond on the left. On the right hand side, double bond on the right. Either way, they're alternating. This double arrow in the middle means that they're in resonance, which means that they're flipping back and forth. When they started doing more research, they realized instead of it being a single and double bond, because those react differently from one another, they realized that with research they realized that they were all the same length. They all had the same amount of power. They all reacted the same. So they've started abbreviating it with a hexagon with a circle in the middle, saying that those are all the double bonds that are being shared. Well, this equal amount of sharing throughout all 6 carbons has created a situation that is actually extremely stable. And so there are a lot of benzene rings found in nature and that are man-made that are extremely strong. And here's the representations again. Once again, this is the most normal way, the most common way you'll see it represented, because it's also the most accurate. Give you some ideas of where they're found in nature and in health. The aroma that you smell in vanilla has a benzene ring associated with it. Then we have some pain relievers and things along those lines that have benzene rings in them. Now let's take a second to review what we've learned already with the functional groups. For instance, here's an alcohol. Remember, you need to memorize all of these. This would be an ester because it's an oxygen surrounded by 2 carbons. Aldehyde is here. This is a carboxylic acid. Make sure you remember to memorize all these functional groups. So when you're naming the aromatic compounds, you're going to be naming them based upon the benzene ring itself. So you're going to actually say benzene. And then you're going to circle and name the substituents like we did before. So because CH3 is methyl, it's methylbenzene. Since Cl is chloro, it's chlorobenzene. However, there are some that have common names to them, meaning that these are just ones that you have to memorize and then add to it. For instance, this is the methylbenzene that we just saw. This was common for many, many years, and so therefore they kept the name toluene. So if you see this arrangement with the methyl on top, you're going to call it toluene rather than benzene at the end. If it has an OH, it's phenol. If it has NH2, it's aniline. You're going to want to memorize these. So you're going to make flashcards that have the name on one side and then the structure on the back. So when we're looking at this, when we're trying to name, here's that CH3, the toluene. So instead of putting toluene, or instead of putting benzene at the back, they put toluene. Then you look for the substituents. Cl is chlorine, so it becomes chloro. Start counting at where the substituent is. Now, ordinarily you want to count from the alphabetical order one. However, since this is the common one and it's including the CH3, we're going to start counting there. That means it's on the third carbon is a chlorine of toluene. Here, if we compare it to the previous ones, there's no ones with chlorine up here. So therefore, this one is just benzene. It doesn't have a special name. So here's our substituents. They're both chloros. Because there's two of them, they put dichloro. Start counting or go in the direction of the substituent because you want these numbers as small as possible. 1, 3 dichlorobenzene. And then finally, if we look at the previous ones, phenol has no H on it. There's our phenol. That's going to be our 1. On the second carbon, there's a chlorine, which is chloro. So 2-chlorophenol. Alright, so if we're looking at the names of these, here's our chain. It doesn't have CH3 and H2 or OH on it, so it's just going to be plain old benzene. That leaves the hexane out. The circle inside makes it benzene, not cyclohexane. We're going to keep the number off of it because there's only one substituent. Since there's 2 methyl groups, where it's going to be a dimethyl. They're all dimethyls. 1, 2, 3. So it's 1 and 3 dimethyl. There you go. So now we're drawing the structures. Benzene is a hexagon with a circle inside. On the first carbon and the third carbon, 1, 2, 3, there's a chlorine on each. There's 1. Now the second one, toluene, there's benzene. Toluene has CH3. On the second carbon, we want a chlorine. So if that's 1, that means 2 must be here. And there you go. So now we're going to review all the way back from the beginning with the organic families. So you're looking at which family these belong to. This double bond is making this an alkene family. They're all connected to one another. That means it's a cyclo family, or a cyclical family. Triple bond, or alkynes. And then we have benzene ring here, which is part of the aromatic family. There you go. I said cycloalkane. And that's the end of chapter 11.